So we have the integral from 0 to 1 from e to the x cosine x less than or equal to, they say, e minus 1. Okay, no one can integrate this, so don't even try. So I know that x is between 0 and 1. Would you agree? Well, what about cosine x?
Well, you have cosine 1 and 0.
Yeah, it will be cosine 1 and will be cosine 0, which is 1. Right? Okay, so for now, let's look at this. Since I'm multiplying by e to the x, which is a positive number, right? Then I have e to the x less than or equal to e to the x cosine x less than or equal to cosine 1 times e to the x, right? So far, so good? So then the integral from 0 to 1 dx, the integral from 0 to 1 dx, the integral from 0 to 1 dx. So far, so good? So this portion is this part. So now I want to analyze this. That's all I need to do next. So the cosine 1 is a number. It goes outside. Cosine 1 radian. Oh, I'll see what it is. And e to the x from 0 to 1 dx. Okay? Now, one more thing that I could have started from the beginning with, no matter what x is, I could have started with cosine x being between 1 and negative 1. And this would have been good enough and not have to worry about this cosine 1, which is definitely less than or equal to 1. Cosine of anything is less than or equal to 1. So I really don't have to include this. I can just jump to this part in which this is not even here. So I'm looking at this and I'm looking at this. So this can go away really. So dx, e to the x dx is e to the x from 0 to 1. I plug in 1 is e to the x. I plug in 0 is 1. 1. And that's the right hand side. So I can start from the beginning with this. And I multiply by e to the x, negative e to the x less than or equal to e to the x, cosine x less than or equal to e to the x. And when I integrate everything from 0 to 1 dx, then I have the integral from 0 to 1 e to the x cosine x dx is less than or equal to e to the x from 0 to 1, which is e minus 1. And that's good enough. Any questions?
I don't like those.
Now, can we go backwards? Meaning, do we still have to work on chapter 5? If you say yes, we can still work on chapter 5. Is there any problem from here other than this one that you would like to go back to?
I think it was one after that. Using the
By the derivative?
theorem of calculus.
Very good. Yes, let's look at the extra credit.
It wasn't on the suggested review question, but I didn't even think about that until I got to the test.
Okay, that's okay.
Right? No, it wasn't on the review. Was it really?
Mm-hmm.
I must have totally missed a section then.
There was like 10 of them.
Were there? And then after I left, I think I remember the right way to do it.
Good. So what we do have to do here?
It's when you have to split it into two, right?
Right.
Boxes. And
Yes.
negative and
So this is the integral from 2x to whatever you
I
want.
think I got the right answer, but I did it the wrong way. Or I just skipped that part right there.
Good. What now?
Make the first one negative and flip it.
Right? Because it's a property of the of definite integrals.
Wait, that's not correct. So it's 2x squared.
Oh, yeah, it is.
Right?
Thank you. So now I can find the front.
That's where you just substitute.
Good.
Yeah, I think that what I did was I substituted in tangent x and then did a minus and substituted in 2x squared. So I think I got the right answer at the end.
We'll see. So
But I think, but I didn't do the steps. So, yeah, 4x to the 4, or
I'm sorry. Of course, x
Oh, okay.
over.
4, or 1 plus 2x squared. Oh, no, I didn't have the right answer then. Okay, so.
Plus
C squared.
this is it. Of course, you can rearrange it a little bit, but I'm fine. You know, negative 16x to the 5th over 1 plus 2x squared plus tangent squared secant squared over 1 plus tangent x.
Okay, that one.
Next problem from the test. Anything that you can remember?
So, I mean, just to clarify, because I kind of got mixed up and then I had to go back. So the summation of I, right, that would be n times n plus 1 over 2, and then summation of I cubed, that would be that same thing squared, right? Okay.
The most difficult one is I squared, which is n plus 1 times 2n plus 1 divided by 6. Good. Anything else? I'm sorry, I would have graded these, but since I didn't have all of them, I'll wait till Wednesday. Sorry about that. Good. Anything else? Can we go back then to chapter 4? Yes? Okay, let me tell you what to expect from chapter 4, and you'll tell me. Do we need anything else from chapter 5, by the way? Okay, from chapter 4. Newton's method, optimization problems, graphing functions, the max-min, of course, the mean value theorem. So that's all in chapter 4. What would you like me to start with? I cannot stress enough, you must retake those tests 1, 2, 3, and 4 between now and Monday several times, and you will have to come back on Wednesday and say, I have questions on this, or before the final. I will be here also between 3:30 and 5 o'clock on Friday, 3:30 p.m. to 5 p.m. on Friday, if you want to stop by and ask questions. I will review with another class that I missed Wednesday with them. But with them I fell behind. With you I didn't. We finished way ahead of time. So again, if you have any questions, let me know.
What were the different categories again?
Yes,
Newton's
Newton's method, optimizations, graphing a function, using everything, and the mean value theorem. In number 3, in chapter 3, differentiating, product rule, quotient rule, implicit differentiation, related rates, and linear approximations and differentials. Exactly what you had on the previous test. And in chapter 2, limits and continuity. Limits at infinity, horizontal asymptotes, and vertical asymptotes. And the derivative of a function. Okay, what would you like to start today? I'd like to do half today and half on Wednesday, or try to do everything today and everything again on Wednesday.
How about related rates?
Okay. Very good. That's in chapter 3. Let's look at the end of chapter 3. I'm going to go directly, not to the review, but directly to linear related rates on page 248, page 249. I don't know if there is anything left. Oh, yeah. Yeah, problem 12. Just caught my eye. It's in red as well. On page 248. If a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, what do I write? Its surface area decreases at a rate of 1 centimeter squared per minute. ds over dt decreases
Negative
1 centimeter squared per minute. Perfect. Find the rate at which the diameter decreases when the diameter is 10. We cannot denote the diameter by d because dd is a problem. So let's denote the diameter by z. So what are we asked to determine? Let's read the problem one more time. If a snowball melts so that its surface area decreases at a rate of such and such, find the rate at which the diameter decreases when the diameter is 10 centimeters.
So dz over dt.
Good. When z equals 10 centimeters. This is the question. Good. Normally, nobody remembers the surface area of a sphere. But here's how we determine it. But we have to remember something. We know the volume. What is the volume of a sphere? Thirds pi r cubed. The derivative of this is the area. So the area, I'm going to denote it by s. The area is, when you differentiate this, what do you get? With respect to r, that's the only variable anyway. So that's the area of a sphere. You differentiate the volume, we get this. Okay, so I know now that ds over dt equals -1. I shouldn't write it one more time, it's clear. Okay, per minute. So I will differentiate both sides here, but I really don't want to differentiate before I change r into
Z.
over r equals right? Z over 2. Right, so this will be nothing else but 4 pi multiplied by z over 2, everything squared. Because r is z divided by 2, correct? So then from there I continue, I have 4 pi z squared over 4, very nice. This becomes pi z squared. Okay. So now I know that ds over dt, from here, the only variable is z. So please differentiate this side, which is ds over dt, and differentiate this side and tell me what to write. 2 pi z times,
Oh, dz over dt.
this is what I want to solve for. How do I solve for dz over dt? What should I do to both sides?
We'll divide by
2 pi z. So ds over dt is at the top. 2 pi z in the denominator. And now you can give me anything you want and I'll plug it in. Not up till now, but now I'm ready. dz over dt is, and I'm told when z equals 10 centimeters.
So it's
Negative 1
negative 1 over 25.
over 2 pi multiplied by
10.
Good, so I'll approximate that. Put it in the graphing calculator. So it's divided by 2, divided by pi. And what is that by 10? Oh,
It's a tiny little number.
I plugged in something. Yes,
Negative 0.157.
yep. Measurement unit, please. So negative 0.01592 if you want. Measurement unit.
Centimeters per second per minute.
Yep, that's it. That was a nice one. Okay, any questions?
So I did negative 1 divided by 20 pi, and I got a different answer than what you got there.
Let me write down what you wrote.
What did I do wrong?
Okay, let me see. What did you write?
I did negative 1 divided by 20 pi in my calculator.
If you did not put parentheses around 20 pi, then you're wrong.
Oh, because it's, yeah, let's see what, yeah, okay.
Because the calculator divides negative 1 by 20, but then the answer gets multiplied. Yeah.
Okay. Yeah, I got the same answers you got.
But your calculator is sophisticated, so
Yeah, parentheses is what it needed.
good. Any questions on this? Any questions? Now I'm just looking for a second at the opinion, student opinion form. Only 2 out of
Oh.
5. So you only have completed it. So
It's in my car.
you only have till Sunday. Beyond Sunday, they'll be closed. So I'm hoping I can not force you to. I'm not telling you what to write, but I'm just asking you if you could look at those. Okay. So I only have 2 out of 5. Okay, ready? Next question. Are we staying on this or moving back to?
Yeah, let's do another one.
Okay, very good.
If there's any we haven't already done in class yet.
Okay. We did the spot line. We did the man walking. Okay, I remember we did the baseball.
I don't think we did number 14.
Number 14. Let's do number 14. Very good. On page 248. At noon, ship A is 150 kilometers west of B. So here's B. Here is A, 150 kilometers. A is west of B, 150, at noon. Ship A is sailing east. So A is going this way. Let me use a different color. So A goes, oh, I'm sorry. A goes this way at 35 kilometers per hour, and B is sailing north at 25 kilometers per hour. How fast is the distance between them changing 4 hours later? So here's what happens. So they start 150 kilometers apart, and they do this. And this is the distance between them. So this one covers this distance, and this one covers this distance. One more time. This distance changes with 35 kilometers per hour. This distance changes with 25 kilometers an hour. And at some point I say, stop. Well, I can't stop them, but I can say, well, one is here and one is here. So this is the distance. Again, I cannot use D, I have to use Z. So at some point in time, that is the distance between A and B. Okay, so this is A with a star, and this is or a star or a prime, and this is B with a star. Okay, so at that instant, which is 4 hours later, from noon to 4, I need to know what is the rate of change of Z. So the question is dz over dt when time is 4 hours later, what is it? I cannot use 4 hours, I cannot use anything before I find the Z, before I differentiate the Z, and then I can plug in. So I have to find a function or a formula or an equation, anything that has Z in it. Can anyone give us an idea?
Area of the triangle.
I wouldn't go with the area, I will go with the Pythagorean Theorem.
Oh, yeah, yeah.
So I have Z squared equals, I'm going to call this distance Y and this distance X. So obviously it's X squared plus Y squared. But I have to find an expression for X, and I have to find an expression for Y. And I do know something about,
You can differentiate both sides.
right. So I think I'm going to say this is Y and this is 150 minus Y. Because I don't know how fast this is changing, but I know how fast this is changing.
Okay, so wouldn't we substitute
Yeah, I can determine that. Sure. But I'm going to use this Y and this 150 minus Y. Okay, very good. So, can anyone, when we differentiate, let's differentiate if you want right now. So this is 2z dz over dt equals 2x dx over dt plus 2y dy over dt. Of course, I will simplify both sides by 2.
No, I mean, what I was saying was that when you use the Pythagorean theorem for the triangle, and when you change one of the legs to 150 and minus y, like in the Pythagorean theorem, instead of having y squared,
That will be one.
Oh, yeah, then I have to, if I change it, yes, I have to have 150. Okay, in that case, I'm going to use this. But it's easier, it's better if I use y and 150 minus y because I do have dy over dt. Yes, in here, yes.
Yeah, yeah.
So I have 150 minus, yes. I changed it, but I didn't change it in my problem. So I have 150 minus y times negative 1 times dy over dt. Yes, I forgot to change it in my formula. Very good. So I will get rid of 2. So I have z equals dz over dt equals x dx over dt minus, or if you want to distribute, you can write plus, y minus 150 dy over dt. Now let's see what we have. Do I have dx over dt? How much is dx over dt? 25 kilometers an hour. Very good. Do I have dy over dt? Which is 35. Very good. Now, I do know that dz over dt equals x, I'm going to leave some space for it, multiplied by 25 plus. I'm going to leave some space for y minus 150, multiplied by 35. And I have z in the denominator, which is the square root of x squared plus y minus 150. No, it was 150 minus y. But it doesn't matter when I square, but I don't want to confuse you. Negative y plus 150 squared. 150 minus y. Okay. So now we're asked to determine, I'm looking for my, what up? Okay, so now we're asked to determine dz over dt when time is exactly 4 hours. Good. So how much is x 4 hours later? Assuming uniform motion, which means distance equals rate times time.
So X would be the,
So this is, this,
so it will be 100.
yes, 25 times 4. Correct. Very good. So this will be then 25 times 4. Now here, what about this piece or this piece? It doesn't matter, right? Just y, because I put y minus 150. Because I had to differentiate, and that's why I changed that. So now I want to find y. How much is y?
140.
Yeah, yes, because it's 30, it's 7, yes, it's true. 35 times 4. And the same thing with x here will be 25 times 4. And the same with y here, it will be 35 times 4. Now all I have to do is plug everything in the graphing calculator. Let's do this together. Oops, nobody can see what I'm doing. Okay. Careful. Plenty of parentheses we need here. Parenthesis for the top. You're right. 25 times 4 is 100, and 100 times 25 is 2500. Just to minimize the number of parentheses that I have to use. Plus, in parentheses, 35 times 4. Although I know it's, what is it, 140, right? Minus 150. Close the parenthesis and multiply by 35. And close the parenthesis for the denominator, for the numerator, divided by the square root. And in parentheses, I have 100 squared. Okay, and plus. I know what that is, right? It's 140 minus 150, or 150 minus 140, which is 10. 10 squared is 100. And close the parenthesis, and I get 21.39. So what is 21.39? Measurement unit. Thank you. So the distance between the two of them changes at at a rate of 21.39 at the particular instant when t is 4 hours. Are we still staying on this, or we move on to something else?
I'm okay if we move on.
Okay, would you like to graph a function? Would you like Newton's method?
Oh, yeah, if we do the method, just to say the calculator part.
Okay, good, so let's do that. So let's choose a problem, and Newton's method was in chapter 4, section 4.8. After optimization problems. 4.8. On page 342, okay, 24 it is. 24. So if it says all roots, I only need one. Because if you show me that you know how to find one, then I'm happy. I know you're going to be able to find the others. 24. So there is a graphing calculator assigned there. So because of how many maximum possible roots can this have? Yes. So let me see if I copied that correctly. Yes. I have to put in the graphing calculator because I have to find 1 unit length interval in which I start with the initial value and so on and so forth. Correct? Good. So in the graphing calculator, in y equals, I punch in x to the 5th. Oh, I'm sorry. X to the 5th. And then minus 3x to the 4th. Oh, yes, of course I always do that. Don't torture me, give me something here. If you have it. Minus 3.
Between 1 and 2
Okay,
should work.
Okay.
Closer to 1.
okay. So between 1 and 2,
Did we do the same problem?
I'm not sure. Did I copy something else?
I did 23. I put 23 in. Yes, keep going. I plugged in 23. I'm losing my mind.
Okay, this is contagious because I normally do that. Okay, so minus 3x to the 4th plus x cubed. And then minus x squared. And then minus x plus 6. Okay, so now I go to second and table, and I start punching in numbers. Okay, I'm going to say -1 is positive, and 0 is positive. I'm going to say -2 is negative. So between -2 and -1, I found my first solution. -2 and -1. Do you agree? Okay. So therefore, next step is I will denote all this by f of x. So this is my f of x, x to the 5th minus 3x to the 4th plus x cubed minus x squared minus x plus 6. And then f prime of x obviously will be 5x to the 4th minus 12x cubed plus 3x squared minus 2x and minus 1. Agreed? So then I know Newton's method is xn plus first iteration. It will be xn minus f of xn over f prime of xn. So let's say I start with x0 equals -2. Then x1 will be -2 minus f of -2 divided by f prime of -2. And so on and so forth, right? Instead, I would like to create a function which is x minus x to the 5th minus 3x to the 4th plus x cubed minus x squared minus x minus 6 divided by 5x to the 4th minus 12x cubed plus 3x squared minus 2x minus 1. And I start by plugging in this function, -2, and then I plug in the next answer, and then I plug in the next answer. How many digits do you want?
Let's try 4.
4. I think 4 is solid. 4 decimal digits. And that's where I stop. But I have on the test, I have to write the answer to the first iteration, the answer to the second iteration, and whatever, and show where I stop. So let's put in the graphing calculator.